Hey guys! This is part 2 of the Adaptive Meshes series going into some cool asset creation. We will be tackling some cool tips and tricks which could be of help when doing procedural modeling. Alright, to start this video off I want to go into reverse so we can understand a little bit of what we are going to make. So in the end we have this lattice construction, but then we separate it in a few parts. We have the pillars and we have the lattice creation geo. Okay, and you can see this hole over here, and that's the first thing we basically do, or well one of the final things. So we have this this selection, this group, and everything in here we're going to be deleting in a certain way, and that's what you can see over here. That gets deleted. Now then we have here some fancy stuff with the pillars. The pillars getting also getting deleted in a certain way, and the pillars which are part of our initial bottom walkway are getting enlarged to go to the top, and then those are used basically with some connect adjacent pieces stuff and then some fancy deleting to create this final result. If we go out of this thing, then you can see that we started with nothing else than a basic wireframe for the pillars and some fancy sweep for where the road was. And this is then derived from our initial spline and terrain. And that's going to be what we're going to be doing in this video. We're going to start by placing a geometry node, as always. We go inside and we need a few things. We need our initial curves we're going to play with, and we need our grid. So this grid is basically our terrain. Let's scale it up a little bit to 100 by 100. Increase the subdivisions a bit, and let's place a mountain node. So this is the terrain we're going to be using. It doesn't need to be that much fancy, it's just to prove that we have a terrain and it works. So let's set it to a little bit larger, the element size, and let's change the height a bit. Alright, for now that will be fine. Now let's place down a curve and another curve. So we have two curves and they merge. Now let's draw some lines. So select your curve, draw some lines. Boom. There we go. And also do it with the other one. And for now this will be fine. And let's place down a subnet. And this is your beginning. Now let's change our initial curves a little bit so we are sure they are above our terrain. This will become really handy later, because we're going to make something above the terrain, not below it, which makes sense. And then after this we will start by cleaning up our curve, which is the basic thing to do when working with a spline based system. Okay, that's looking better. So let's dive into our system. And first, the first input is going to be my terrain. So let's just give this the color blue. And my second input is the line. Also, let's give it the color blue. And now the first thing to basically prepare your line is what I always do is place down a point triangle. Of course, there are many ways to do this. I'm just using this simple little trick right now. I'm setting the up vector y to be 1. Now then I'm placing our sample. So we have the perfect sample size which we want. And then a polyframe. And the polyframe is going to use the tangent name to set the normal. Alright. And now let's clean this up a little bit. I'm going to place a null node. Let's give this the color purple. Let's set the shape to something we recognize a little bit better. And let's call this spline. For the terrain, I'm just going to copy this one over. And I'll be calling this terrain. This is the first step we do, basically the importing of our attributes and all our information. And let's put a nice box around it, a network box, so we know what this is. Let's go to step 2. which first requires us to place down an object merge. Now let's wire in the terrain in here and the spline. So first let's do the spline. Set the color of this one to blue. And do the same for the terrain. Now let's rename these. Spline in and terrain in. Alright. Now place down a line. This line is going to be our control node for a bit. So I'm going to color this one yellow. Just so we remember where everything is going to be. Then place down a sweep. And let's place down this one. Oh, that's the terrain. Sorry guys. And let's wire in the spline. Okay, now you can see it's vertical right now. Our line needs to be horizontal. And we want it to be in the middle. So copy parameter, paste it in there and multiply it by minus 0.5. Alright, and the direction needs to be, of course, also in the x direction. Now, there we go. Now, we also want this one to be a little bit better for us, so let's place this one to skin without a closure. Alright, let's go. Now, I already changed this, but in the example, make sure you don't have subdivision set, that you have the subdivision curve turned on, and I'm using length of 2 right now. Alright, now place down a convert line and wire in this from the sweep. Now place down array node, and the terrain is going to be our collision geometry, and the convert line is going to be our original geometry. Now let's set this to project arrays, which is nice. It needs to be a vector. Delete channels. And set this to -1. There we go. Now we're gonna place 2 group nodes, one for the top points and one for the bottom nodes, bottom points. Oh, one for the bottom points. It needs to be points. Let's copy this and make this top. Okay. Wire this in for the bottom and the convert line for the top. Alright, and place down a add and then merge. Wire those in there, wire it into the add node. Let's delete geometry but keep points, do it by group, skip every end point, type down endpoints, and let's get the point number from our merge. And let's divide this by 2. And now we have our straight lines. This is basically the first thing for step 2. Now let's place some new out nodes. I'm going to use null nodes for this again. So let's just copy this one, place it down there, and let's call this out pillar splines. And I'm gonna need the output from the sweep, so let's copy this one over. And let's call this spline sweep. Okay. Now that was step 2, and let's make a nice network box around this so we know what we got. Let's create the profile of our pillars. So place down a grid. Set the grid to XY plane. Make sure it is a size of around, let's say, 0.13. And let's copy this parameter and copy it over there. Okay, let's have a look at this one. We don't want to have rows, we don't want to have columns. And place down a poly bevel. Now set this poly bevel to points. And we only need 1 for those. Alright. Now this is going to be our profile. Place down another subnet. And wire in this one, in the third one. And we need 2 object merges. One object merge is going to refer to our pillar splines, because we're busy with the pillars. And let's change the color to blue. And the other one is going to be a copy of our spline in. Alright. There we go. Now, wiring the pillar splines as the first one and the spline into the second. You can of course switch this around however you want. For my system I use this. Yeah, do whatever you feel like, whatever makes most sense to you. Now I like to color my subnets green, so I know, oh, that's a green node. No, that's something important, which helps me a lot. Let's dive in. In here I'm gonna make two subnets. Subnet 1 is going to be called the pillar geo creation, and the other subnet will be called the lattice segment creation. Alright, let's color these green already. And now the pillar geo creation is gonna have 4 inputs in total. It's gonna have number 1 in the first place, then it will have number 3 in the third place, and the other 2 we're going to be creating. Now let's select our 2 and let's copy over the line that we have over here, and let's throw it in here. Now this line doesn't need to be a fancy color or anything, so let's put it back to normal. What we do need from the other line is the length value. So let's copy this and let's set it into the length, and want it to be twice as long. Now place down a grid. This grid is set to the XY plane. It has 2 rows and it has a size of our line distance, but then multiplied by minus by 1.3, not minus. Okay. And the other one, that's going to be a variable, and for now I'm gonna set it at 3.4. 3.4. But just be aware, I'm gonna write yellow, that you can change something in this node. Alright. Now let's place down a sweep. There we go. And let's make sure this sweep also has auto closure. And now let's place down a polyfill. So we have a nice manifold object going on here. Alright. Now this other line is also going to be using a sweep. Oh. And this output is also skin of auto closure. Okay. Now let's go. I'm gonna wire in the polyfill into the second group of both of these, and then I'm going to wire in this sweep into the as the fourth input. And before we forget, let's go to this grid and let's set the center to 1.8. And let's dive into our pillar geo creation node. Okay, first place down a point flop. With this point flop we're basically going to switch around two attributes. So place down a bind and a bind expert. And so let's set this to up. Oh. And that's a vector, and do the same for the other one. And the normal is going in here and the up is going in here. Alright. Now when you have done that, let's place down a sample. This sample, let's turn on maintain last vertex. And then place down a convert line. Now place down a group node. We're going to be grouping based on our second input. Also, let's make these blue, so I know I have something about them. And we're going to be grouping the points, and by bounding region, by bounding object. Okay, there we go. That's what we want. Now we're going to be deleting this, but first the sample can be set a lot higher. I think something like 1.35. Yeah, that should be fine. That should be alright. Okay, and then place a delete And this delete is going to be deleting our group 1. Okay. Yeah, don't forget it to set it to point. Now place down a transform node. The transform node is going after our 4th input. Okay. And just let's translate this down a little bit, something like 0.04. Just to make sure our points are not gonna select themselves, basically. Okay, then place down an array. And the collision of the array is our transform down swept geometry. And what we're arraying is the other part, and we're going to be arraying this stuff up. So it needs to be project arrays, vector. Let's delete these channels, and it needs to go up. Okay. And don't forget to select only the top points. And this will mean that only the points on the top of each pillar, which also can hit this swept surface, will be transformed to the top. Now let's copy over our sample. So we make sure we have the same type of geometry again. And you can already see a little bit over here that because we have this maintain last vertex stuff turned on, that they kind of follow the terrain. You can also reverse this so it follows the walkway, but for now it follows the terrain, which is it's serving its purpose. Now you can place down a sweep node, and this sweep is this is the backbone for the sweep, and we need our final 3rd input for this sweep. And let's make sure we have some geometry. Alright, there we go. Let's place a polyfill and add some normals so we have some cool geometry. Alright, there we go. Now you can place a output node. Never forget to place an output node because it's incredibly annoying if something happens and you don't know why, everything goes wrong. Okay, but we also need a second output. This output is going to be coming after the blast that we place, or the delete. So place another output. And let's make sure this is the right index. So this one is set to 0 and this one is set to 1. Perfect. And let's throw this into from the delete. Alright, and now we have 2 outputs. Now the second output needs to go into the first input of our lattice segment creation. For the next part we're going to be repeating something from the first tutorial. You can still do this without having followed the first tutorial, but I would advise, if you really want to understand what happens here, to follow the first tutorial first. Now let's dive in and let's create these two with a blue color. Let's place down a carve node and a transform. And the transform, I want to be setting it to in the y direction minus 0.3, just moving it down a little bit. And the carve node we are going to be setting to a very low value and a slightly higher value over there. And that should about do it. But first I noticed that I forgot a few nodes. So I forgot a few nodes after our sample, which was first a polypath. Oh, polypath. Together with a fuse. So let's wire those into each other. And then a group promote. Because we have a few lines too many over here. And we can delete those by selecting the top group, which is points, and which can become primitives. And now you can see we have everything selected except those two, and those two are not really necessary because there's already enough support down there. So let's place down a blast. And this blast is going to delete everything except the top. So delete non-selected, and there we go. Now this is what needs to go into that sweep. And then this is also what needs to go into our output. Alright. Now, and if we go in here, and now our carve works way better. As I already said, it's going to be a little bit similar to the last video. So place down a polyframe. Now this polyframe, we're going to use the tangent name to set the forward attributes. And then we're going to place the same sample we've been using everywhere else. So let's just copy it over. And let's place that one. Oh, don't like this. And then place a fuse, just to be sure. Plus a connect adjacent pieces. Now this fuse, like sometimes we're gonna get something in the top here, which we don't really like. So let's set this a little bit larger. Just to remove some small artifacts we can have, like those two over there. Then place a connect adjacent pieces. I want the maximum search points to be something around 12. The search radius can be quite large. Maximum search points can be actually larger, but first of all what you need to do is to set it to adjacent points. And now you get a wireframe. And now you can set the search radius to something you like. I think 2 right now is alright. Max search points, what we want over there, is something like 8. Alright. Or maybe a little bit larger, 12 or something. Depending on how crowded you want this to be. Now the next thing we're going to do is group this based on our second input. So we're going to set this again to points and keep in bounding regions, bounding object, and we have some points which we can use to delete stuff. So first place a group promote. With this group promote we're going to set this from points to primitives. And let's name these segment points, or delete me, that's a nice name. So group delete me from points to primitives, and only if it's completely surrounded by group points. Alright, now let's place a blast. And let the blast delete those. There we go. So you can change a little bit with the settings of this. So right now we still have a few too many over here. But I think for this we can better increase the width of our original. Or to be more precise, right now we're using this grid and we still have the width we can change. And let's set this to 1.4. Alright. Now let's go in there. And we can see that it's still not there. Let's lock this frame. Let's go in here and let's change this value to something like 2. Alright, it's looking better already. Okay. Let's go in there again. So we just deleted this geometry. Now I'm going to add a little bit of a beautifier basically. So I'm going to place a sort. And with this sort I'm going to do a random sort on the primitives. And then I'm going to place a delete. And I'm going to do a delete based on range. Delete 1 out of that 10 or something like that. And now we have a little bit more of a variation, which is nice. Now let's place down a facet. Now the fun part starts. So we have our separate points. That's basically what this facet is going to do. Set it to unique points. We have a lot of points. And let's start with the next part, which is similar to the first video. First create a VOP network, a point VOP. So there we go. Let's set this to detail. So make sure this is set to primitive, not detail. And we're going to set the position of the primitive to each point as a rest value. And we're going to be calling that centroid. Alright. And this needs to be a vector, of course. Let's change this name to primvop. And let's grab this attribute promote to change this to a point. So from primitive point, and let's grab the centroid. Place down a point flop. And in this point flop, vector to float. Let's grab the point position. And let's grab the centroid. And also place a vector to float for that one. Now a float to vector. And we only want the x and z value from both of these. We're gonna negate the bottom one. Could also negate the top one, doesn't really matter that much. Add these two together. Let's grab the absolute value. And then with a vector to float again, add all these values together. And after that, place down a compare. And with this compare, we're gonna set this thing to equals less than and promote the second attribute. Alright. This is going to be controlling our switch, which is going to be deleting our point, or is not going to be deleting our points. So a constant, set it to integer, -1, and wire in our original point number. There we go. And let's have a little bit more variation. And remove point, wire in the result. There we go. Removing all our vertical numbers, or our vertical rows. Then place down a polyframe. This polyframe we're going to be using to set the normal for each and every of our primitives. Or it doesn't have to be set to points, doesn't matter that much actually. Place another point flop. And in this point flop, we're going to place down a cross product. Grab our normal and wire it into the second part. Let's normalize this just to be sure, and our cross product is going to be pointing upwards. And bind export. Now we have our up value. This also needs to be a vector. Now place down another point flop. And inside of this point flop, we will be adjusting our forward. So let's place a bind and a bind export. And I'm just going to make sure if our forward is still looking downwards. Yeah, that's all right. Then let's set this to forward. Make sure it's a vector. This one also a forward. So make sure it's a vector. Now place down a cross. A cross product. Let's wire in the normal and our forward. And another cross product, which is grabbing our forward and the result of our first cross. And let's wire this into our bind export. Alright, cool. Place another point flop. Let's go inside. Place two binds. One for our centroid and one for our centroid, which is a vector. And one for our forward vector. Also vector. Many vectors today. Then place an add. Oh. What vector did I use for this one? Oh, doesn't matter that much. Okay. Then wire in our point position into the add. And wire in our forward. Then let's get the distance. between our centroid and our forward, or now our centroid, or our, so let's get this from this new position, and our centroid, let's get the distance, and also let's get the distance from the centroid and our original position. Alright, then compare these two and set it to whichever one is larger, greater than. Place down a switch and place down a multiply. The multiply we're going to be using to multiply our initial forward vector. Then place down a negate. Wire this into the first wire in the first one, and then wire into the negate. Then place in add and wire in our original point position. And let's get our geometry of output and let's wire it into the point position. And now you can see we have this cool offsetting power for all of our segments. We're going to be needing a distance for this, and this distance is equal to this so this grid, this size we need, copy perimeter, or however you call it. Let's go into our lattice segment creation, and let's copy paste it here, and then divide it by 2. Alright, and that's the variable we needed. Now place our final point fob, not the final one, but for this little transformation piece. Let's place our point fob, and let's go inside. Let's place a bind. Let's get the centroid again. And with this centroid, vector to float. And copy, we just want to have another vector to float. And we only need the y value of our vector to float. And we're going to place a mix, which is going to use both y values. And we're going to promote the bias. Float to vector. And we're going to be combining these two. And this is going to be our next position. Now, if we play with this, you can see we are pushing them outwards of each other without doing any fancy venom tactics or whatever. And this will help us with creating nice segments. And in the end, let's place a fuse, just to be sure we have something double, or doesn't really matter that much, and an output. Because never forget your output nodes, that becomes annoying. Let's go one up. Now we need to create a geometry for our segments, which we're going to do in another subnet. So place another subnet. Let's make it green. And let's call this lattice geo creation. Okay. And let's dive inside. First thing we want to do is placing down a point fob. And in this point fob, we're going to place down a dot product. So this should be very similar to what you did in the first video. And let's get the forwards with a bind, of course. And let's set this to vector. Then I'll put it over there. And let's place this in a power. Oh, and set the exponent to be -1. Because that's what we need, of course. So we're going to take the inverse. You could also take the inverse, but yeah, who cares? And a bind export. Set it to p-scale, and there we go. And we are also going to be using our forward for our normal for now. So let's wire those two in. Next up, let's create the profile of our wooden beam, which we're going to set to a size of 0.13.
and something like 0.05, nice and small. Then we don't need that many rows, we don't need that many columns. Place down a polybevel. And the polybevel, we're going to do the same trick. So that the points, only one division is needed. And my view, oh yeah, of course, my viewport was locked. And there we go. So make sure this is a very tiny size, otherwise it looks weird. There we go. Place down a sweep. And those need to be reversed. We have some, okay, we have something going wrong definitely here. Alright, so I found a mistake, and pretty stupid mistake, which was using the position over there. And this needs to be normal. But also, just to make sure that you guys also have this, in all your fuses, make sure you don't have the update point normals turned on, because that can also screw up stuff. So make sure that one is turned off. Alright, now we have our sweep. Let's go to the output, skin unclosed, and we have our lot of segments. Now, we want to polyfill these. Or we don't, depending on what you're doing right now. Actually, I'm not going to do that. I don't think it's necessary, because we can just fuse these with the other ones. So make sure you have an output node. And let's color this purple. And now we can merge these two together. And there we go, we have the first beginning of our lattice construction tool.
Make sure to check our Patreon. In time we will be sharing more tips, tricks and assets. And you can also find the HDA used for this video. Handy to see how to deal with those pesky UVs and making it ready for Game Engine. If you enjoyed the video, make sure to drop a like, and for now, this was Dokai. Bye bye.